Welcome back to Maths with Mrs. J. We've just introduced the change of base rule, and I want to show you how useful it is for getting either approximations or exact answers for various logs without us having to change into index notation. If I had something like log of 7 to base 3, first thing, we should have some idea in our head of what sort of number we're looking for. We're saying to ourselves, what would you need to raise 3 to give you 7? Now we know that 3 to the 1 is 3 and 3 squared is 9. So our answer should be somewhere between 1 and 2 and on the closer side to 2, one would think. Because we're going to use our calculator, we're just going to change to base 10. You don't even have to write the base if you don't want to. So log of 7 on log of 3. At that stage, it's still an exact answer. Then you can use your calculator and your log key, and then you can round off to 2 decimal places, and you get it's about 1.77, which is within the realms of what we were expecting. We thought it would be somewhere between 1 and 2 and sort of closer to 2 than 1. The next one, again, we might as well go to base 10. Again, let's just think about what we're expecting. What would you raise 7 to give you 50? Well, we know 7 squared is 49, so we would be expecting a number just slightly over 2 here. All right, again, change of base rule, log of 50 on log of 7. I'm changing to base 10 because it's clear that there's no other base that's going to help us here, and this will be able to use our calculator and we'll get an approximation. And we get about 2.01, which is roughly what we were thinking. Just to remember how to use the rule, this number here goes in the numerator, this number here goes in the denominator, and both numerator and denominator have to be changed into the same new base, which in this case was base 10. Right, let's look at this next one. Now, here's an example where we don't want to get an approximation. We can actually get an exact answer here. Notice that 32 is not 4 to the something. However, 32 is a power of 2 and 4 is also a power of 2. So how about we change them both to base 2 and go from there? This is where this really comes in handy and we don't need to have to go back to index notation all the time. All right, log of 32 to base 2, well, that's log of 2 to the 5th to base 2, which is, this is log of 2 squared to base 2. I'm going to actually just get rid of this one, so we've got a bit more room, which is, of course, what do you raise 2 to give you 2 to the 5th? It's 5. What do you raise 2 to give you 2 squared? It's 2. So you can leave it as 5 on 2 or 2.5 is fine. Let's do the last one. So if we had log of 125 to base 0.2. Now just bear in mind here, 0.2 is 1/5, isn't it? 125 is 5 cubed. So how about we change both, change base into base 5. All right, so we want to have base 5 in numerator and denominator. All right, so 125 is 5 cubed. 0.2, let's just do a bit of working here. 0.2 is 1/5, isn't it? Which is 5 to the negative 1. So in our numerator, what do we raise 5 to give us 5 cubed? Well, clearly it's a 3. What do we raise 5 to give us a 5 to the negative 1? Clearly it's negative 1. 3 divided by negative 1 is negative 3. Just a couple of things to be careful of here. Do not cancel the log symbols, whatever you do. It is not something called log times something. You also can't cancel your 32 with your 4 because this goes as a package deal with its base. So does this. All right, so just be a little bit careful and bear in mind what you are actually doing if you're working with logs.